I started my career at NASA. I was 16 years old. No field experience whatsoever, and additive manufacturing was just slowly becoming more and more of a priority. When I started my career at NASA, it was a top 30 priority, and when I left my career at NASA, it was a top 3. Noticing that it was becoming more and more of a critical need, I was getting a demand signal, not just space, but defense, mining, remote constructions. Just hearing that being repeated again and again gave me the signal that says, okay, how about we do something about that?
All right, welcome back to another episode of DIB Innovators. I'm here today live from the Space Tech Expo again in Anaheim, and I've got a great guest, Madison Feehan, founder and CEO of Space Copy. So this company builds 3D printers infrastructure with a goal to get on the Mars and Moon and be able to print from Mars and Moon using just the natural resources there. So super cool to dig into this and super excited to chat. So thanks for joining.
Absolutely, pleasure to be here.
Great. So give me your background. So as we start off, you've got pretty impressive background. So how did you get to become the CEO or found this company, Space Copy?
I still wonder that, to be quite honest with you. I started my career at NASA. I was 16 years old. No field experience whatsoever. And I learned everything from the bottom up through other people in my network that were working in planetary science and astrophysics and heliophysics. I didn't even know what those things were.
At 16, weren't you going to school?
I was going to school.
Oh, while working at NASA.
While working at NASA. I got a part-time gig. It was during COVID as well, or like right before COVID. So a lot of things were able to shift online, gave me more flexibility while I was completing studies, and went on to work there for 6 years, mostly handling things like cyber program offices and dealing with the next innovation that was getting funded through the next fiscal year. It's really cool.
Okay, so then NASA, what after that?
During that, I founded Space Copy, and then finally left there about 1.5 years ago, so that I could pursue Space Copy even further. I worked a bunch of roles kind of in between consulting. I was a startup founder at another company, and then I kind of transitioned to fractional work, and then eventually left that organization so I can really hone in on what we were doing at Space Copy. And now I do small business mentorship and early career mentorship for people trying to orient themselves into careers in STEM while still managing and growing a thriving business.
That's a lot to do. So what need did you notice that NASA, created the opportunity and the desire to start Space Copy?
A few things. I'm trying to prioritize them. When I look at critical technology gaps that were coming from NASA, and from input channels like the Planetary Decadal Survey, from the critical gaps and civil space shortfalls, additive manufacturing was just slowly becoming more and more of a priority. I'd had my eye on it for almost about 10 years now. Looking back, when I started my career at NASA, it was a top 30 priority. And when I left my career at NASA, it was a top 3. So noticing that it was becoming more and more of a critical need, that I was getting a demand signal from other people in the commercial space, not just space, but defense, mining, remote construction, saying, hey, we can benefit from the use of additive manufacturing. We have these constraints and these shortfalls. And just hearing that being repeated again and again gave me the signal that says, okay, how about we do something about that?
That's cool. So share with the guests, I kind of gave a quick overview, but like, what is Space Copy? What are you doing? And then, what current customers, just kind of walk me through the founding of that, what your mission is, and have you had to pivot in that time frame?
Oh, plenty of pivoting. So, okay, here's how I describe us, and very technically, we're an in-situ logistics and additive manufacturing company. There's a bunch of fancy words for rugged 3D printers. They're built for extreme climate. The most austere communities. We're on the front lines of combat. We're on the front lines of mining and remote construction, natural disaster sites, flooding, wildfires, etc. And then on the space side, we work from LEO to lunar, everything from capturing space debris and turning that to feedstock, to 3D print antennas and increase the lifespans of satellites, all the way up to some lunar surface infrastructure plans that we have for being able to put 3D printers on the moon with the next round of Artemis spacecraft that's going up to the surface. And then eventually, one day Mars. Got a little bit of that Elon Musk mindset, right? What's really unique about the way that we build product is our 3D printers are hardened to take any kind of material. Polymer-based, ceramic, metals, ISRU, so regolith, soil, sand. We can intake that. We grind it down into a feedstock. We have little sensors and spectral systems that are identifying the composition of that material. And then our 3D printers are entirely autonomous. And we're building any kind of infrastructure from interlocking bricks for housing and roadways, rocket launch pads, vehicle repair parts, precision tooling, about 250 different parts, using all of those different material bases, then deploying it into the most extreme climates that you can imagine, from the Arctic to the dark side of the moon.
How big are these machines?
We got two sizes. We've got desktop ARIS. ARIS stands for Aggregate Extrusion for Regolith Infrastructure Systems. It's about the size of a laptop. We've got these larger ones that are about a cubic meter in size.
Okay. And you are currently deployed? Like, how many have you sold? Like, how far into this journey are you?
So we pre-sold 300 of them. We're in the midst of making those 300. Our second gen tech is being released this summer under a NASA contract. So we're building it down in San Diego, and then we're going to go demo it at NASA Marshall Space Flight Center at the end of this summer, and then commercialize and expand from there. The last few years has definitely been a focus on R&D, just make sure we got the product right, and that was matching the voice of the customer. And now that we collected about 300 or so pre-orders, mass deployment for 2027 and 2028 is the plan.
What is the hard science, the hard tech with what you're doing? I mean, this sounds like a lot, but
All of it.
yeah.
If I was to summarize that, two things. First and foremost, the material science. 3D printing is built on one class of materials, right? You're just printing with plastics, or it's just metals, or just ceramics and so forth. Being able to do all of that in a single mechanism, it's not easy. The second part of that is being able to match the equipment to the environment that it's being deployed in. When I imagine kind of the benefit to the customer, it's the reduction in logistics costs. You don't have to manage external supply chains. You deploy 3D printer to the site. It's working with whatever you got. The difficult part is making sure that not only can we work with those different materials, but also can we deploy to those environments? And are the parts that we're deploying, that we're printing in those deployed environments, meeting the specification, whether it's mil spec, NASA spec, an ASTM standard? Is it safe? Is it effective? Is it high grade? And is it going to last? Those are some of the primary challenges that come to mind.
And so tell me the material you can work with again, because some of them I'm like, how do you get it to adhesive? You know, the different sound like space rocks or something you could grab. How do you get that to adhere to each other as you're printing it though?
So yeah, the coolest material that we get to work with is the regolith simulant. So simulated moon dust, eventually real moon dust, and we deploy in 2031 to the lunar surface. But what it is, the dust or the soil, whatever you want to classify it as, it's very much like a ceramic, but it's highly abrasive. It's angular like shards of glass, but the material science behind it is very much like a ceramic. It's about 48% silicon dioxide with trace amounts of metals like aluminum, titanium in it. That in itself, you can 3D print pretty much everything, but then just keep in mind it behaves like a ceramic. So it's got that brittleness, it can crack, it can have pores in it. Beyond that, think of anything that you could grab from a landfill. Plastic and metal scraps. We've worked with food packets from the International Space Station, got thrown out. We're working right now with Zotec F30 aviation foam, which is terrible to try and break down and recycle. Everything from blue nitro rubber gloves and Nomex bags to things that you would find standard in 3D printer like PLA or TPU, peak thermoplastics, different types of metals and different types of ceramics. And often we find ourselves mixing them together and making this slurry of different things. And when it comes to lunar soil, we do have to do like a really high temperature print in order to get it to adhere. And then sometimes we also find ourselves mixing it with some of that other scrap to create somewhat of a binder. So it really sticks for those kind of long duration use cases.
What is is there like a product they're trying to print? Like the biggest use case you've kind of heard across your pre-orders? What are they looking to build?
And we always ask our customers this. So we've got probably a top 10 list. Inside that is anything that's interlocking. So one of our flagship products is these interlocking bricks and tiles that can be used for housing and rocket launch pads and roadways. We use a process called corbelling. where you're 3D printing things that are basically like Lego bricks. They just stick together and you don't need grout. So that becomes really useful. Very basic precision tools like wrenches and hammers, Allen keys, stuff like that. Door hinges, ironically, seem to be a thing that breaks down in places like the Arctic frequently, and apparently it takes 6 to 8 weeks to get door hinges shipped up there. So that's one of the more interesting things I didn't expect, but it's a list of many. The coolest, in my opinion, is right now we're working with some partners in Europe, taking the regolith, so the moon soil, spinning it into fibers, and melting it through the 3D printing process with wool to create a textile that absorbs moisture and repels radiation for astronaut spaces.
Oh, wow.
So I have a really cool job. I get to do a lot of really neat
That
things.
is cool. And so your background, and you told me a little bit before, if we just met, but a couple degrees help you with this. What are your degrees in again?
Yeah, I got an associate's in business and entrepreneurship from Harvard. I got a Bachelor of Commerce from the University of Victoria. I'm getting ready to start a master's degree program from the University of Central Florida that's going to be equal focus of space engineering and business. So that gave me a lot of foundation as an entrepreneur. But I always tell people I learned so much more in the field running a business than I did in the classroom. But I can also thank a lot of training programs. We went through Techstars and Creative Destruction Lab, all the classic startup programs. Immense mentorship and resources is education in itself.
Yeah. What was the most useful, like, support that you've seen? Was it Techstar? I've heard a lot. We didn't go through Techstar, but, or
God, I have to pick one. I feel like I'm going to owe an apology to everybody that I don't pick. I've got beautiful things to say about everybody for a different reason. First and foremost, my family. Their resources and support just by being there along the ride and supporting and guiding, first and foremost. If I was to go and pick from a program, Techstars gave us the first kind of push, and that's what we really needed. And then as we started to develop out more, we went through the Blueprint program with MIT, a program with Singapore Management University. Those guys, amazing people, amazing community. But I really have to hand it to Creative Destruction Lab because it's one of the only places that you can go to where they're not going to coddle you. They're going to throw you to the wolves and make you claw your way back out. And I think that there's not enough startup programs that treat founders like that are there not only to guide you and give you mentorship and resources, but to actually push you to do something. Yeah, I'll classify it that way.
Okay, no, that's a great summary. I appreciate it. There are so many different ways to get into it, and so it's not easy. How big are you guys?
Small. We got about 8 staff members, women-owned, small disadvantaged business, expanding currently. So fingers crossed for another successful year of hires.
And have you raised capital?
We're in the process of that. So we're raising a 5 million seed right now. It's our first foray into dilutive capital raising. We've been carried by grants and contracts right now. We've got a direct to phase 2 right now with NASA. So we've been mostly kind of honing in on that. And then the next 6 or so months, we're going to really focus in on trying to raise from venture capitalists and family offices.
That's great. Where do you see you guys, as this continues to grow, where do you see in 5 years? I mean, you mentioned Artemis, which do you already have that? Like, are you going? You made it sound like you were going. Are you on the?
We're getting there. We've got a Space Act agreement with NASA, so there's things in the works. Signed letter that says, we approve what you're doing and we want to put it on a spacecraft one day. It's our estimate that 2031's the year, just based off of our relationships with them and where the Artemis program's going in general. I think beyond that, if we're thinking near term to the next 5 years, so we're doing the live demonstration later this summer at Marshall Space Flight Center. That will be the kickoff. After that, we're going to go up to the Arctic, put it out in a crate, send it up on a chopper, drop it into the most remote place in the Arctic Circle, actually at an analog astronaut test base that's adjacent to an indigenous community. So we'll be doing a bit of a humanitarian effort, building infrastructure for underprivileged communities at the same time as working with people that are trained to become astronauts and doing it in the Arctic. We're going to bring it back down and work at some different mining sites across North America and do some pilot programs. And then as we step into probably late 27, early 28, we've got a couple launch contracts that we're just finalizing to get to LEO. just get into the zero-G environment and start to take some space debris and work with that. And then, 2031, estimated date for putting that on the moon and actually doing some really cool lunar infrastructure.
I mean, it's so awesome what you're doing. I think this is really neat. I mean, there's 1,000, printing companies out here, 3D printing companies. Is there anyone doing anything like what you're going after right now?
Definitely. There's a good dozen or so companies that are dedicated to 3D printing efforts in space, a lot of which are using things like Regolith. And honestly, they have my full support. It's a really hard industry. I don't even go and call them competitors. I call them competimates because it is such a niche that we need to be able to build a community around doing something so challenging. But yeah, to answer your question, there's a few of them. And each of us has this little interesting technology offering that the other doesn't have.
Yeah, that's great. I like how you put it, competimates. Well, that's good. We're gonna have to wrap this up. It was super enjoyable meeting you. I love what you're doing, and wish you the best. If folks want to follow what you're doing or chase it down, how should they do that?
Yeah, absolutely. So if you're interested in learning more about Space Copy, you can contact us. info@spacecopy.com is our general contact email. You can also follow @SpaceCopy on LinkedIn and @SpaceCopy Inc. on Instagram. We're posting job opportunities for both employment and internship. We're always on the road. This is our 4th year at Space Tech Expo. And we do probably about 25 trade shows a year, so you will always see us around.
Awesome. Well, thank you very much.
Thank you very much. Pleasure.